All right. So, to review about homework expectations, because it is a little weird as we swap from like one chapter to the next, and we haven't taken the chapter 4 mastery yet, because I like to put masteries on Friday because then there's no homework. So, with the chapter 5 homework being assigned, I really would not put that into map until after we get past the chapter 4 mastery. So yeah, like 5, 1, and 2 were assigned yesterday. One combined assignment. So it's due midnight tonight, but I'm not going to put that grade in map before we take the chapter 4 test. So chapter 4 should be your main priority. If anybody has any chapter 4 work left to do, you need to get that done first before you move on to chapter 5. Does that make sense? Because you want to be prepared for the chapter 4 mastery. That makes sense?
Yeah.
Yes? So on the assignment board, you can see our mastery will be on Friday over here on the assignment board. Remember that you guys are that lower left-hand block right there. I might try to raise the assignment board up to make it easier to see, but right now that's kind of all we can do to work with. So hopefully someday you have enough money to become an investor. But when we have investors, what does it mean to be an investor? What does it mean to invest? Jeremiah, don't give it to me. Just let me get there. I know. It just, my brain takes a moment to get going. Jeremiah. Yeah, if I put money into a company, like a lot of people say, if I could go back in time, I'd invest in Apple. And they say that because Apple has made buku amounts of money. If you invested in Apple before they were a big company, you made lots and lots of money for doing nothing except for investing your money. So when you invest, you can buy certain amounts of stocks. A stock is whatever, like a portion of a company. So you become like a co-owner. So somebody, an investor, owns 203.72 shares of stocks. They paid a certain amount for each of those shares. Do we know how much they paid for each share? So oftentimes when I ask a question, I'm not looking for the fastest answer possible. I'm looking for analyze what we're looking at and find the correct answer. So,
this is just another question.
Okay.
The got it about the example.
Oh, did we not do that one either?
No.
I'll circle back to that. We'll do that in a second. So, do I know what each stock cost? Do I know how much?
No.
No, but what do I know about each stock? Dom?
The value of a share of stock dropped 0.15 cents.
Ooh. A share, so each share that he owns, you buy a certain amount of shares because then you share the company, drops by 15 cents. Now, how do we represent a drop of 15 cents? Andrew? Negative 15, so I know negative, and we always like to put the 0 to make things look nicer. Negative 15 hundredths. Now that is for every share. How many shares does he have?
203.72.
203.72. Now, I want to caution you with when we calculate these things. In the calculator, especially the ones that I have available for you to use, because we could approximate this. I could take my 203.72 and make it like a 200, and I could get fairly darn close. But if I want an accurate answer, we get our calculator, right? Because we could set up the multiplication. We could do long multiplication, and we might do a mastery on long multiplication, long division at some time. But now that we're getting up into the secondary level, we use calculators because we want to be efficient and save time. So on this calculator, and I haven't used this yet, so you guys might be blown away, but especially since I know people are getting sick and some people aren't here with us. On this calculator, if I want to type a negative 15 cents or a negative 15 hundredths, and this might take a second because I had disconnected everything. There we go. So on this calculator, what am I actually looking for? If I want to type a negative 15 cents. Sam?
On the bottom row, there's like parentheses, a negative sign, and then another sign.
On the bottom row, or on your calculator, it may not be on the bottom row, but you're looking for what looks to be a minus or a negative inside of parentheses. Now, Dom and I had a great conversation last night about one of your homework problems that hopefully we get to review before we get out of class, and actually I would like to, but this makes it the negative, as opposed to if you use this, that's a minus. That's an arithmetic operation. This is saying that the number itself is negative, so then I can type my negative 15 cents and multiply by my 203.75, what was it? 72. And my answer should be negative because in total I had a loss. Now, if we're talking finances, can I use negative 30.558? I what? We're down $30, but I lost cents too. How do I know my cents?
It's after the decimal, that's how much. Wait, no.
But are there 3 places? Ah, we're going to have to round. The 8 is going to tell my 5 right here in the hundredths place that it needs to round up to a 6. So really, it's negative 30.56. Does that make sense?
Yes.
So in total, let's say that was a day, he lost $30.56. Put a dollar sign out here to be accurate. Now that's just one day. He could make more than that the next day. That's the thing about the stock market. It goes up and down, it fluctuates. You have to kind of be willing to leave your money there and trust that it will eventually make you money. Yeah.
What happens if it goes up and then it goes back down?
Wherever you sell your stock, that's the money you get. So once you buy a stock, your money's in there changing value until you sell it. So say here's where you buy your stock. Let's say you buy stock for $5 a share. Then it goes up and you're at like $15 a share. And your friend is like, man, you should sell. You've made $10 on every share that you bought. You go like, nah, I think it's going to go higher. And then it might go down to like $10 a share. And your friend's like, ah, man, you should have sold when I told you to. And then it goes up to $20 a share. Like, that's the problem with the stock market, is it's very hard to predict. Now, there are people that make their living trading stocks. They're called day traders. One of my brother's friends does that. You have to really have like money to be able to play with, and you have to be able to lose money and have other money that will make money to compensate for that. Sean?
So for the stock, it's mostly you buy a stock, and then once it gets a certain amount, you take it and then you trade it for another stock?
Yeah, you can, so you like cash out. So imagine like being at the arcade and you've won a bunch of tokens, and then you go and you spend those tokens to actually get more like tokens to play more games to win more tickets or something like that. Like a game won you tokens, and I can use those to win more tickets or something like that. So you should be able to do this. Got it. It's the exact same thing as that example. So the last thing we're going to do from this notes is this product right here. So it was in our learning target, but before I mess with multiplying rational values, especially when I have mixed numbers, what do I want to do? There's something that will make my entire process so much easier. Don?
Turn the negative 2 1/8 into an improper fraction.
Yeah, so I want to either convert to a decimal, but eighths are kind of tough to work with, so I could also just convert to impropers. So negative 2 1/8, remember our triangle method, 2 times 8 gives me what? Then I add it with the 1, I get 17/8. Don't forget your negative. So this becomes 3/8 times, and I actually, it's a negative, so I'll leave it in the parentheses. Negative 17/8. Now, do my denominators need to match? No, we're multiplying. This is not important. They do match, which is great, but it's not important. How do I multiply a fraction, which is actually easier than addition? At least most people think it's easier than addition. Jeremiah?
Isn't it just multiply the top and the bottom?
What do you mean? Top times bottom, or what do you mean?
Multiply the numerator by the numerator and the denominator by
2 words summarize what you just said. Straight across. So you're right. You're totally right. But how we work is straight across. Is all you have to think about. 3 times 17. Break this up. Evie, put it down. We don't need a calculator. Break up this multiplication. What is 3 times 10? What is 3 times 7? So, combine those together. We get 51. There's a negative. Make sure you bring the negative. 8 times 8. 64. Now, this is when it gets dicey. Can I reduce? Is there a common factor between 51 and 64 that they can both be divided by? 3 would work with 51. It doesn't work with 64. Any even number, well, not any even number, but I could divide by an even here, doesn't work. Is there anything, Jeremiah?
I'm confused. How'd you get 30 and 21?
So, if I look at, so I'm going to move down here. 3 times 17 is actually the distributive property. So I'm going to distribute my multiplication. 17 is really 10 plus 7. Do you agree with me on that?
Yeah.
I can then do 3 times 10, which gives me 30, and 3 times 7, which gives me 21. So really, it's 51.
Oh, okay, that makes sense.
Break up the multiplication. Do not resort straight to a calculator.
Okay, that makes
Jeremiah?
sense.
Thank you. Thank you very much. But that will not get you a free mastery or anything like that. But I do appreciate that. So, once we break up that multiplication, guys, this is super beneficial to think about right now, because that is a standard in our next chapter. When we're talking about, in this chapter, actually, when we talk about multiplying and we tie in variables, we're then going to have to do this process. So, break it up into factors of 10, 10, 20, 30, 40, whatever your first digit is. Then break it up into your ones place, and that makes your multiplication way easier. Can we reduce this? I can't find anything that we can reduce by, so I'm perfectly happy to leave it with just what it is. Now this was part of one of your homework questions where it said, when you multiply by a positive number less than 1, 3/8 is a positive number less than 1. What happens to the value? It gets smaller or closer to 0. Because, say I have 9 pizzas, and I multiply each of them by a half. Well, now I only have 9 halves of the pizza. So think about, like, when you have those homework problems, analyze it. Don't just try to get the quickest answer. Make sure you're getting the right answer. Before we move on to 5.2, let's talk about that homework problem. So there's a homework problem. I don't really have any open space. I'm just going to make a new slide here. No, it's the exact same problem. So sometimes we don't do the got it because it's the exact same thing. We're not doing the last got it, guys. It's the exact same thing as the example problem. If you have issues with it, come see me. There was a problem on your homework. If you did, Dom, was it the 5-1 homework? If you did your 5-1, 5-2 yet.
Yes.
That looks like this.
Yeah.
Now, this is actually the funniest conversation. Well, it put me in a funny, awkward position. So, can I share? Do you care?
Yes.
So Dom texts me. He goes, Mr. Hudson, my dad is telling me the wrong answer. And I'm like, oh my gosh, now I'm in an awkward position because now I'm going to have to get between a student and their parents and decide which one is right. So I'm like, okay. And Dom was right, which was the funnier part, is that the student was right and the parent was wrong. Now, your dad was right in his own way. Because when we read this statement, this is not negative 10 squared. This is the opposite of 10 squared, then plus 4. Because the other way, what Dom's dad was thinking about, if the negative 10 was grouped in a parentheses to keep the negative together, then it raises the negative 10 to the second power. Negative 10 times negative 10, negative times a negative makes a positive, and then that would be 104, which is what Dom's dad was trying to tell him, because a lot of times back in the older math, we didn't use parentheses as grouping symbols as much, because math was kind of more dirty back then. They didn't do as much to clean it up. Like, so it just didn't look as nice. You know, like so your room. So think about when your mom tells you to clean your room. You're like, Mom, my room is fine. Your floor might be covered with dirt, but you're like, I can still use my floor, right? I can walk on it. So we didn't used to make math as clean as we do today. There are very specific rules today. When you think about PEMDAS, your order of operations, right? Are there any parentheses here? No. So then I go directly to exponents. This exponent is only operating on its base, and right now its base is only 10. This symbol falls into the addition-subtraction category because it is an arithmetic operation. It is like a minus or an opposite. It's only a negative if we group it in parentheses. So we would do 10 squared first. What's 10 times 10? 100. So we get 100 from that. Then we'll apply the negative up front. So we get negative 100 plus 4. And then they are different signs. Which sign has more power? Then find the difference. And you have your answer. Honestly.
Over there, shouldn't you do addition subtraction first?
What do you mean?
Before multiplication?
No, PEMDAS works down. You go parentheses, exponents, multiply, divide, then add, subtract. And we add, subtract from left to right. We multiply, divide from left to right. So that's why when we build the ladder, multiplication, division are on the same level, and addition, subtraction are on the same level. They happen at the exact same time. We just work it left to right. So when we get to here, I've not applied any addition or subtraction. I've done none of that yet. So the first thing I do is apply the opposite to the 100. So the opposite of 100, I can now call this negative 100. Then I have to add 4. When I add 4 to negative 100, it pushes me back towards 0, and I really get negative 96. Mm-hmm.
So you do the multiplication division first.
Well, we do parentheses, but there are none. Then we do the exponents. Then we multiply, divide. But we did not multiply, divide here. We did exponents. The exponent made me multiply.
Suppose you would have had to multiplication.
Yeah, we would do that before any addition or subtraction. Yes. Any other glaring questions from your homework? Nobody else reached out to me last night. So I feel like we were all pretty okay, or we just didn't do it yet, which is okay. Like, chapter 4 is your main priority right now. Any other homework questions? Pressing issues? Cool. Would anyone like to pass on notes? Anyone, I don't care. Just, or multiple of you. You guys are going to have extras, so then just put them in the that math setting bin or whatever. Oh, so you guys saw this just for a moment in the shot. So yes, I almost always have my Swiss Army knife with me. This actually it's not a weapon, it's a tool. This, you know the European trip, the international trip that Phoenix goes on? I've never gone, but when they were over in Switzerland, they went to the Swiss Army the store, and got me this, and they got it engraved with my name, because I'm always, like, fixing things and doing stuff around here. So, the thing that I use most on this... Nope. Scissors. Those are the sharpest scissors ever. And like seriously, when you're out and about like trying to open packages and different things, the scissors on here are like the best tool. That and then just the little knife. I hardly ever open the actual knife, but the little knife, that's a perfect size. Half an inch.
I can't tell you how many times I've broken those scissors.
The Swiss Army scissors? Dude, I've cut through some crazy plastic and they've been alright for me. So maybe it's a user error.
Like the really hard plastic, like when they have like thumbtacks.
Yeah. Like, I mean, you probably have to be careful. That might be what they're missing. Alright! 5354. So, to re-emphasize, because we kind of skipped past it, our learning target for today is that I can accurately perform division of fractions by changing the process into a multiplication problem. Now wait, we're allowed to change division to multiplication? That makes my life so much easier. When I make this change, I also know to invert or flip the second fraction. Now, a lot of you have a little memory trick from 6th grade that you've probably been taught. That's why hands, I bet, just shot up. Jeremiah, why's your hand up?
No, I just wanted to know which one do you hate the most? Multiplication, division, addition,
I don't hate any of them. Hate is a very mean word.
What do you dislike?
Honestly, I love how quiet everyone got because you want to hear what operation I don't like. Honestly, in my opinion, the most difficult operation, but one of the most fun, like, interesting, maybe not fun, interesting, square root. Square roots are cool. When we get into the non-perfect square roots and approximating the decimal value of the square root, it's really kind of cool because we have a method that actually a previous student of mine invented, and I'd never heard of it, but it works very, very well. So it's a cool, like, I forget if I've said this to this class, but I think math is beautiful. Like, everyone has their own definition for what is beautiful, what is pretty. Like, I think the relationships and how things work together, the math you can find in nature and all, like, I really think that math is beautiful. And when that student presented that process to me, it, like, blew my mind. Because square rooting is such a difficult, complicated process, and she had just taken it, like, one step further, and that's where you get that, like, exemplary grade. Where, like, you not only figured out how to do this, you figured out better than what I taught you, which was sweet. So now I use that method. It's called the Rachel method. So, I don't know if she found it, so her name's Rachel. So I called it the Rachel method. So when we learn that, we will learn the Rachel method. She's in high school now. Rachel Shaw. I don't know. She's cool. Her mom does a bunch with music. So every multiplication statement has two related division statements. So I want you to kind of give yourself a two-tiered section. I want you to set up a multiplication problem and then the two division problems that use the exact same numbers. So I'm going to give you an example, but you're not allowed to use my example. 2 times 3 equals 6. Likewise, 6 divided by 3 equals 2, or 6 divided by 2 equals 3.
Oh my god!
Now, hold up, I'm going to give you one more example, but you're also not allowed to use this.
No, you better not.
I just wrote one down. No.
4 times a half equals 2, right? Half of a 4 is 2. We agree with that. So I could then say 2, the number that I ended with, divided by, well, if we look at the top, what I can see is if I grab one of these, my answer will be the other one. So 2 divided by 4, well, think about setting that up, 2 divided by 4. Well, of course that's a half. Sorry, this should have been blue. So then what we're saying is 2 divided by a half is 4. Which this is where things get funky. So, on your own, with a partner, with a neighbor, whatever, if you want to verify, check, challenge, I'm going to give you like 2 minutes to set these up. I want you to use at least one involving a fraction. At least one of them has to involve a fraction. What? One of them has to involve a fraction. So you can steal an example very similar to mine. You just cannot use exactly what I have up there. That's fine. I set up a very simple one to make it straightforward. Now remember, we are starting with a multiplication statement. Then we create the divisions. We're starting with a multiplication, then we create the divisions. By the way, you can ask me, do you want me to call you Katie or me? I just want to know what you want me to call you. I think your name is super cool. So until you tell me to call you, I'm probably going to call you. Your name is super cool. Oh, we need to watch. Maybe we'll. I have a film about cicadas and all the math involved in cicadas. So maybe tomorrow. Maybe we'll do that tomorrow. Dumb. All right, so bring it back together.
I'll take his sticker. I'll take his sticker. He doesn't work.
I gotta find somewhere to put it. I'll put it on my computer screen or something. All right. I want examples involving fractions. So what fraction examples did you set up? We've talked. Who haven't I? Initially, we haven't talked yet today. I didn't want you to go as far as mixed numbers. So that's fine that you did. I just don't want to confuse people. So I'm gonna like for now. I'm just looking for like one integer, one fraction.
12 times a half equals 6.
All right. So hold on. 12 times a half equals 6. I agree with that. So what related division statements did you create?
I didn't get the finish. I'll do them now.
Okay, so we take our answer to start, right? Each of them has to start with my original answer. So it's going to be 6 divided by. Okay, so 6 divided by a half equals 12. And 6 divided by 12 equals a half.
Mr. Hudson, Dom really wants to share something.
I know. Dom has shared a lot. I appreciate that he wants to share, but I got to make sure everyone has a chance. Elena?
3 divided by 1/3 equals 1.
Ooh, we got to start with the multiplication statement.
No, I mean 3 times.
Yeah, that's what I thought you meant. So, we say 3 times 1/3 equals 1. I love it. Very simplistic. I like simple problems to get those rules in our head. So, what are your division statements?
1 divided by 1/3 equals 3.
Hold on, you're going too fast, so I gotta change colors. 1 divided by 1/3 equals 3, and
1 divided by 3
1 divided by 3 equals 1/3. Now, this is really weird, right? Because I'm saying 6 divided by a half. Now, be very careful. This is not saying divided in half. That is absolutely not what this statement is. Can we, like, come on, man.
I got my pencil.
Yeah, but you're making it a whole big show to get him his pencil back. Thank you. What this is saying, if I have 6 of something, say I have 6 pencils, and I give these pencils to half of same. I divide these 6 pencils among half of a person. The answer is going to be how many pencils would a whole person have? Well, if half of a person gets 6, how many would a whole person get?
12.
12. That's how this works. But the process doesn't make much sense in our head, right? How can I give things to half of a person or half of an animal or half of a, like, those processes don't make sense. So we instead apply the process called keep, change, flip. Most of you might remember from elementary, so I'm going to capture this, but then I'm going to use the top one just because I have space.
Mr. Hudson, have you seen the song?
I mean, there's a lot of different, like, how to remember it. So when I have division involving a fraction, what we're going to do, if I have any of my smartboard pens, and this is why I use KCF, because they're each different letters. It's not Kentucky Fried Chicken, it's keep, change, flip. So, and the reason I also don't say keep, change, change is change is an ambiguous word. It doesn't really have a specific meaning. When I go to change division, that's pretty straightforward. What do I change it to? Well, the only related operation is multiplication. But we would much rather say flip, because if you think about the learning target we had, multiplication and division are inverse operations. 1/2 and 2 are inverses of each other. They're actually multiplicative or multiplicative inverses. So I keep my 6, I change to multiplication, I flip my fraction, which actually this would be 2/1, which then is just 2, and that is the simpler way to get to our answer. Jeremiah?
What's that one thing called where, like, you have two fractions and then you switch the,
You mean two fractions like a fraction equal to a fraction, or?
no, I just mean just two fractions and then you switch the one on the right, and then you cross the top off and the bottom off.
You're talking about proportions. You're thinking about a fraction equal to a fraction when you cross multiply, maybe? Well, I gotta hurry up and get through some of this so you guys are able to at least start your homework. So show me later, because I don't want to confuse people. So now, hold up. Let's create one of those multiplication statements using 0 and see if the same thing works when we change it into a division statement. So let's say like 5, and you can write down my example. 5 times 0, right? Well, what happens when I multiply 5 times 0? I get 0. So when I look for those related division statements, I would have 0 divided by 5 equals 0, or 0 divided by 0 equals 5.
What?
So now wait, so this one can kind of make sense. If I have 0 of something and I divide it to 5 people, each person gets 0. I'm doing that right now. I gave you each 0 pizzas. But if I have 0 of something and I divide it to 0 people, well, every person that doesn't exist gets 5 of something I didn't start with. Yeah. More so than the fact that we can't do 0 divided by 0, we cannot ever divide anything by 0. So we're never allowed to do this because the situation is nonsensical. It just doesn't, math has to make sense. It is a logical process. If it doesn't make sense, it can't be done. I can't take 0 of something and divide it to 0 people and end up with each non-existent person getting 5 of something that never existed. That, like, it makes so little sense. Elaine is choking. Alright, so now we got to find the quotient. What's quotient mean? Answer to a division statement, right? So, division of integers is easier to set up vertically. Jeremiah, can you stop, please? Thank you, buddy. Remember rule number 1. Do whatever you want as long as it does not impact learning. That's distracting me. It's literally impacting my teaching. I'm sure it's impacting your classmates. This is easier to set up vertically. So, put your first value on top and your second value on bottom. Now, we talked about these rules with multiplication, and our multiplication rules are the same as division rules. What happens when I have a negative and another negative? I have 2 negatives involved in my process. Jeremiah?
Do they still cancel each other out even though they're fractions?
They still cancel out. If I have 2 negatives, whether I'm multiplying or dividing, every time I have a pair of negatives, pairs become positive. In multiplication division, pairs become positive. So, what I want to do here now to make this problem easy is just try to reduce. If I can get my denominator to a 1, then my answer is just the numerator. So, I ask myself, can I divide by 5?
No. Wait, yes.
Yeah, because my 125 can be divided by 5. So, I just do that, and I get 25 as the answer. Might as well write that below. Now, if you want to check this work, turn it around. I can just multiply straight back through the same way that we divided. If I take 25 and I multiply by 5, I can get 125. Now remember, there was a negative 5 actually, and a negative 125. So for my answer to be right, those negatives need to be there, and they are, so we're good. Yeah.
What happens to the negative?
So it's just like when we were multiplying. If you have, give me a second. If you have a debt that you've accrued, let's say you are borrowing $5 every week from somebody. So now, let's say it's been 5 weeks. You've borrowed $5. So borrowing $5 puts you in debt for 5 weeks. You now have a debt of $25, right? But if I go back in time 5 weeks, your debt of negative 25, if I break it up going back in time 5 weeks, tells me how did I get that debt? $5 every week. So it's thinking about like the opposite of a negative situation, the opposite of a debt or the opposite of a withdrawal is positive.
So what happens to the negative?
They disappear. They cancel each other out.
So if that had been the common negative.
They're, well, not in a division problem, but in a multiplication problem, the two negatives that compare would cancel, and the one negative that still exists would still be there and make the problem negative. If there's an even number of negatives, the answer is positive. If there's an odd number of negatives, let's say negative 3 times negative 2 times negative 4. These two negatives cancel each other out because the opposite of a negative. But then this negative still happens, and I get negative 24.
So in a division problem, since there were only...
There were two, they canceled out, it becomes positive.
So suppose one of the negatives hadn't been there,
Right,
that would be negative 25.
correct.
Okay.
Because if it can't pair, it stays negative. Alright, so the quotient of any two non-zero. So this gets into proofs. We are going to work with proofs as you get up in your mathematical career. It's asking me, is this true? It's a conjecture. A conjecture is like when you say something and you don't know if it's true or false yet. So the first question we could ask is, can this be true? Can two integers divide and make an integer? Yeah, like if I have like 8 divided by 4, that makes 2. Integer divided by integer, I got an integer.
Yeah?
Does this always work?
No.
So to say no, we have to provide a counter example. A counter example is something that disproves a conjecture or a statement or a hypothesis. So if your hypothesis is when it rains, like things catch on fire, I don't know, that'd be a weird hypothesis. But all you have to do is show that when it rains, things don't catch on fire. That's your counter example. All we have to do is show two non-zero integers in a division that don't equal an integer. So, can it be true is different than is it always true. So, can this conjecture 1 be true? Yes, 8 divided by 4 is 2. Is it always true? Well, let's try, what about 8 divided by 5? Would that be an integer? No. That would be 1 3/5, which this would actually come out to be 1.6. That is not an integer. That is a partial value. This is not true, and we can show that with this example. So we would say no, and we would provide a counter example. Now, conjecture 2, all it's saying is for two numbers a and b that aren't 0, I could have the negative in front of the value, I could have the negative as part of the numerator, or I could have the negative as part of the denominator, and it doesn't make a difference. Is that true? Well, to look at that, is the opposite of 8 divided by 4 negative 2? Yes. What about negative 8 divided by 4? Well, that's negative 2. And what about 8 divided by negative 4? That's negative 2. They all hold true. So conjecture 2 is correct. We could say true or yes or whatever we want. Any questions on how we prove or disprove a conjecture? Conjecture is a statement that has not been proven yet. So this is just restating that rule that it doesn't matter where your negative is. It can be in front, it can be on top, it can be in bottom. It doesn't make a difference. So we want to show some examples of this. So it says use these integers to write at least 3 different quotients, p divided by q, equivalent to the rational number, the answer. So I need 3 different, so I'm going to section this out for 3 different. I need 3 different divisions that would give me these answers. So to get negative 3, we want integers. Jeremiah? How could I get negative 3 as an answer?
Negative 3 divided by 1.
Okay. I'm going to take that and make it a little bit more difficult. I agree with what you said is right, but I'm just going to go ahead and double both of them. Negative 6 divided by 2. Just to make it actually not involve a 1 and be a bit more interesting. Andrew?
Negative 18 divided by 6.
Now I agree, but what it's asking me to do is just like they showed up here. I might need to scoot for that. It wants me to show that I can change where the negative is and it doesn't change the answer. So to just move the negative here, this could turn into putting the negative out front and say the opposite of 6 divided by 2. Or it could be, where else could the negative go? We had it on top, we have it out front. 6 divided by negative 2. And all of these would give me the same answer of negative 3. That is everything for now. We might wrap this up tomorrow. We might do something else. But remember, your mastery for Chapter 4 is on Friday. Get that work completed as soon as possible, please. You have another riddle?
Yes.
Is it impossible again?